Hello everyone, welcome to my video classes. Today's topic is zero electric field point for two charge system. Instead of using the conventional method, we will explore a shortcut approach that makes problem solving faster and more efficient. This method is a unique approach developed by me aimed at saving time and simplifying calculations. Let's get started. Zero electric field point for two charge system. The two charges are having different magnitudes. When the charges are alike, we will study where is the zero electric field point, and when the charges are unlike, where is the zero electric field point. When the charges are alike, the zero electric field point is present between the two charges and closer to the weaker charge. Let's take the two charges. The distance between them is, let's mark the D. Remember, D is the distance between the two charges. One is the stronger charge, another one is the weaker charge. Mark the strong charge as capital Q, weak charge as small q. As per the above statement, the zero electric field point is present between the two charges and closer to the weaker one. As per this scenario, so there will be somewhere here. Assume at this point the electric field is 0 and this point is at a distance of x from the weak charge. Okay, same thing we can get for the negative charge system. Okay, so our aim is to find the x, that is the distance from the weak charge to a point where the electric field is 0. The formula for that is x equal to d over root of capital Q by small q plus 1. So in this approach, when the magnitude of the charges, capital Q means the strong charge, small q means the weak charge. So if both the charges are having the same prefixes like micro, nano, milli, pico, like this. If they are having the same prefixes, no need to write here. This is one advantage. And another advantage is that, no need, only we have to deal with the magnitudes. Okay, no need to write plus minus like this, only with the magnitudes we have to deal. Another advantage with this formula is that if the D is given in meters, the answer x also we get it in meters. If the D is in centimeters, the answer of x also in centimeter, like this. No need to convert the distance also, like this. Okay, let's get into the next one. When the charges are unlike. So where is the zero electric field point? In this case, the zero electric field point is outside the two charges and closer to the weaker charge. Let's take two charges. One, the distance between them, let's take the standard as the D. One is strong charge, another one is the weak charge. In this case, the zero electric field point is present outside the two charges. And which side? It is closer to the weaker charge. So this one is between the two charges. So here the zero electric field point is not present between them. So it can be this side or this side. Okay, outside means this and this. So as per the above statement, it is closer to the weaker charge. So this side is present. Okay. So let's mark at this point the line joining the 2 points, extend it. At this point, the electric field is 0. The same conventions we have to take. X is the distance from the weaker charge to a point where the electric field is 0. Okay. The formula for that is similar formula, only one difference is that is minus. That's it. Okay. Easy. I hope it's easy to remember the formulas also. Let's start. When the two charges are having the same magnitudes. First we study when the charges are alike, and then when the charges are unlike we study. When the charges are alike, it means we cannot say this is strong, this is weaker. Both are having the same charge. Capital Q equal to small q. Both are equal. So in this case, this root of capital Q by small q, this value becomes 1. So 1 plus 1 becomes the 2. So exactly the 0 field point is present between the two charges when the charges are having the same magnitudes and when the charges are alike. So here, so x can be either we can take here to here x or here to here x. It's up to us. Both are the same. Okay. So this is the easiest way. No need of any formula, nothing to do. Just whatever the total distance between the two charges is given, divide with 2. We get the answer. Now, when the charges are unlike, where is the 0 electric field point? As per the statement, it is outside the two charges, closer to the weaker one. So here there is no weaker at all. So both are having the same charges. Okay. So outside means maybe this side or this side. Whatever it may be, let's move on to the formula. So this part becomes, when the charges are equal, so this part becomes the 1. So 1 minus 1 becomes the 0. When 1 minus 1 becomes the 0, anything divided by 0 will give you the infinity answer. The answer we are getting is infinity. It means that there is no point. There is no point outside the two charges. Maybe not between the two charges also. There is no 0 electric field point at all. Okay. So in the line joining the two charges. Is this clear? Okay. Let's do some problems on this. Two positive point charges. One is 16 microcoulomb, another one is 4 microcoulomb, and they are separated in vacuum by a distance of 3 meters. Find the spot on the line between the charges where the net electric field is 0. We have to find where the electric field is 0. The picture is given. Very good. As per our statement, when the charges are having like charges, okay, where is the 0 electric field point? It is between the two charges. Okay. Before that, let's mark Q1 is 16. 16 means this is the strong charge. Q2 is here in this case the weak charge. So Q1. So where is the 0 electric field point? It is between the two charges somewhere here, and it is closer to the weaker one. So somewhere, let's mark this point. Here the electric field is 0, and which is x distance from the weaker one. Okay, the total distance between the Q1 and Q2 is the d equal to 3 by 2. As per the formula, we have to use x equal to d over square root of the strong one by the weaker one plus 1. So which is equal to 3 over square root of the strong charge is 16, the weak charge is the 4. No need to write micro. So plus 1. So which is equal to 3 over this part is root of 4, which is equal to 2 plus 1, which is equal to 3 by 3. So final answer is x equal to 1. So the d value is given in meter, our x value also in meter. So which is from the weaker charge. Weaker charge is from 4 microcoulomb. That's it. We can also write from the strong charge also. From Q1 also we can write. If this is 1 meter, it means that this distance equal to 2 meters. So 2 meters from the Q1 also we can write up to us. Let's move on to another question. 2-point charges, one is 20 nanocoulomb, another one is 10 nanocoulomb, are located on the x-axis. The Q1 is present at x equal to 0 position, Q2 is present at x equal to 1 meter position on the x-axis. So where on the x-axis the electric field will be 0. So very clear, both are positive. It means like charges, and one is the strong charge, another one is the weak charge. Okay, so as per the statement, the 0 electric field point is present between the two charges and closer to the weak one. Okay, so we can assume like this. This is Q1, this is Q2, and it is closer to the weak one. So this distance is x and the total distance is the d, which is equal to 1 meter. Okay, the formula is x equal to d over the strong one by the weaker one plus 1. Why plus 1? Plus 1 is for the plus like charges. Okay, that's it, we are ready. So 1 divided by square root of strong is 20, the weak is 10 plus 1. So which is equal to, the final answer is, let me do the calculations, 1 over root 2 plus 1. I got the answer as 0.414, okay, 4142 something. Okay, so if the d is given in meters, the x also in meters, and as per our technique, this x value is from the weaker one. Weaker one is from 10 nanocoulomb charge. Okay, plus this one. Okay, we can also write like this also. The answer given here is from the 20 nanocoulomb. So how to get this answer? Just total distance 1 meter minus whatever we got our answer, 0.414. That's it. We get this one, approximate value. Let's move on to another problem. This time the 2-point charges, Q1 is negative minus 20, okay, nanocoulomb. Q2 is plus 10 nanocoulomb. Okay, they are located on the x-axis. It's almost the same problem, no change, only the change is the plus and minus symbols. Okay, so okay, look at here, this is what? This is 20. 20 means the strong charge, 10 means the weak here compared to 20. So like this, same problem. So in this case, they are the unlike charges. Unlike charges means what is the formula for unlike charges? Okay, let me draw the scenario. This is the charge Q1, this is the charge Q2. The distance between them is 1 meter. Where is the electric field? 0 here in this case. Obviously outside, okay, closer to the weak one. So So somewhere here, let's assume here at this point the electric field is 0. So which is x distance away from the weak one. Okay, so the what is the formula to find the x? The formula is d over square root of the strong one by the weaker one, because the charges are unlike charges, minus 1. That's it. So 1 over square root of stronger one is 20, the weaker one is 10. No need to write nano. That's it, minus 1. So the answer I got using the calculator is 2.41 something, 414. So this is from what? This is always from the weaker one. So Q2 from plus 10 nanocoulomb charge. That's it. So here the answer also showing the same. Let's go to another problem. 2-point charges, Q1 is plus 20 nanocoulomb, Q2 is minus 10 nanocoulomb. So one is plus, another one is the minus. Okay. Are located on the x-axis at x equal to 0 and x equal to 1 meter respectively, where on the x-axis the electric field will be 0. Okay. So which formula we use? Just you think. They are the unlike charges. One thing, unlike means plus minus unlike, and one is the strong, another one is the weak. Okay, so that's it. So where is the electric field? 0. For unlike charges it is outside the two charges, which is x distance away from the weaker one. That's it. We can directly find the formula. X equal to d by square root of capital Q by small q. Unlike means minus 1. So d how much? D is the distance. That's 1. Square root of the strong one is 20. The weaker one is the 10. No need to write plus minus symbols in this formula. That's it. Minus 1. So obviously it's like previous one. The answer is 2.43. This is from the weaker one. So from the weaker charge is minus 10 nanocoulomb charge. That's it. Let's go to another problem. Two equal charges plus 10 nanocoulomb each. This is different. Are located on the x-axis at x equal to 0 and x equal to 1 meter respectively, where on the x-axis the electric field is 0. Look at here. In this case, the two charges, one is 10 nanocoulomb, the positive one, another also the positive charge, 10 nanocoulomb. So there is no strong, there is no weak. They both are equal. So they both are like charges. So when both are like charges, where is the 0 electric field point? It is between. When they are equal in magnitude, then especially the electric field point is exactly in the middle. So if the total distance from here to here is 1 meter, okay, so take from any charge, in the middle means from any charge at 0.5 meter, you get the point where the electric field is 0. Okay, the formula is simply distance by 2, 1 by 2, that is equal to 0.5. If the d is in meter, x also in meter. So anything we can write. Okay, anything from any charge. Let's move on to the last problem. Two equal and opposite charges. One is positive charge, another one is negative charge, but both are equal. 10 nanocoulomb, 10 nanocoulomb are located on the x-axis at x equal to 0 and x equal to 1 meter respectively, where on the x-axis is the electric field is 0. Okay, so in this case, obviously when we see the plus minus symbols, okay, our technique is the point is outside. Okay, the formula we use it, the full formula is square root of capital Q by small q minus 1. I told you before this part becomes capital Q by small q, 10 by 10 becomes the 1. Okay, so d means 1 meter over square root of 1 means 1, 1 minus 1 becomes 0. If you use the calculator, it will give you the error. Okay, so simply x equal to infinity. Okay, it means we can say that there is no zero electric field point for this case. I hope you got this technique is useful for you. Okay, thank you very much.